For Lesson 12.7, you're introduced to three new formulas: the volume of a pyramid, a cone, and a sphere. I'm choosing to work out problems numbers 20, 21, and 22 on page 599. Please make sure on your note sheet to include all of the work that I've shown here. Also have a calculator ready so you can pause the video and double check as I type in the formulas or type in the numbers. And hopefully by now you're realizing there's a theme to all of the lessons in this chapter, and that is to show your work. Show the formula. Every time you write it, it's one more chance for you to remember those formulas. Substituting numbers in is a huge part of algebra, and of course, verifying your answer. In this case, it's fine to use a calculator, but just so you know, I'm usually typing in my answers 2 or 3 times just to make sure that I get the same answer 2 or 3 times in a row, because there are mistakes that can be made when you're using calculators. Of course, there's mistakes that can be made when you're also using calculator or paper and pencil, but I just wanted to show you on my calculator what I type in for each of these problems. So on number 20, I have a hemisphere or a half sphere, and so I'm going to be using the formula for a sphere, which is 4/3 pi r cubed. And then in the second step, 4/3 is a constant, pi is a constant, and I'm just substituting in 7.2 for my radius, and I'm going to cube that. And then since it is a hemisphere, I'm going to divide my answer by 2. So there's a couple of different ways you can type this in. You could start by typing in 4 divided by 3, which equals 1.3 repeating, and then multiply that by pi, and then multiply that by 7.2 times 7.2 times 7.2, which equals 1,563.5. Now there is another different way that you can, oops, I forgot to divide that by 2 because it's only half a sphere, a hemisphere. So the final answer is 781.7. So that's one way you could type it in. I just have a habit of always starting with my exponents first because I know that comes first in PEMDAS. So I can type in 7.2 and then cubed, and then I can times that by pi, and then I'm going to times that by 1 point and as many 3's as I can fit into my calculator, and then equals, and then divide by 2. I get the same answer of 781.7. So however you choose to do that, it's fine with me. 781, it does say to round to the nearest tenth, so 781.7, and then don't forget your label of cubic centimeters. Okay. On number 21, I tried to follow my suit from previous problems where I'm showing the steps for both parts of this figure. So the top cone here, I have volume equals pi r squared h. Volume equals 1/3, and pi are constants. The radius of the circle is half of the diameter, so half of 6 is 3. 3 squared, of course, is 9, and then multiply by 15. Go ahead and take your calculator out and multiply pi times 9 times 15 divided by 3, or you could type in 0.333, as many as you can fit on your calculator, times pi times 9 times 15. Notice that so far this chapter we have not used 3.14 for pi. We're actually using the pi key on the calculator. So you never want to just type in 3.14 unless the directions tell you to do so. The volume of that top cone is 141.4. If you apply the same formula to the bottom cone here, all that changes is the height, which is 7. You should get a volume of 66. And then for the total volume, we're going to add those two together, and you should get 207.4. And that is in cubic inches. So make sure you have that work shown, and the final answer, 207.4 cubic inches. For the problem 22, again, I separated it out into the cone on the top and the cylinder on the bottom. We have 1/3 pi r squared h for the cone on top. You're just substituting numbers in and typing them in on your calculator. Double check it 2-3 times to make sure you get the same answer. I round to the nearest tenth, and I got 19,242.3 for the cone. For the cylinder, capital BH, remember that capital B represents the area formula for the base. In this case, the base is a circle, so that capital B turns into pi r squared times the height. Pi times 35 squared times the height, 55, gives you 211,664.8. And when you add those two together to find the total volume, you're going to get 230,907.1. And that is measured in cubic feet. So this one's really kind of interesting to think about how much water is in that. If you have a ruler, 1 foot by 1 foot by 1 foot, imagine that box that's 1 foot by 1 foot by 1 foot and fill that with water. And then think about 230,000 or 231,000 of those, how much water that will actually be. It's quite a bit of water to visualize. So hopefully working through those 3 problems will help you with the problems on your worksheet. If you have a question, just request a Google Hangout or shoot me an email and we can work through some of these together. The biggest thing to remember though is to show your work, write those formulas down and substitute numbers in, and double check your calculations at least twice.